All right, well, good afternoon or good morning or good evening from wherever you're joining us. My name is Chris Battisto, and I'm the current chair of the Information Technology and Interoperability Committee through the ESIP, the Earth Science Information Partners Group. I'm joined today with Keenan Gans, who is our community fellow, and our guest speaker, who is Eni Awowale from the NASA Goddard Earth Sciences Data Information and Services Center. Eni is a scientific software developer with a bachelor's degree from the University of Maryland, majoring in GIS and cartography. She is interested in geospatial ecology, quantitative data analysis, and data management, with a strong interest in Python software development. Today, Eni is going to be sharing her work on the xarray.Datatree model. And with that being said, I will go ahead and hand it over to Eni. Oh, and really quickly, we will have 45 minutes for a presentation, followed by 15 minutes for Q&A. So I ask that you all please stay muted, and we will get to your questions when the Q&A portion has arrived. And it looks like Eni is able to share her screen, so I will go ahead and hand it over to you.
Awesome. Thanks, Chris, for that. I'll go to full screen mode. Can you all see that as a full screen?
Looks great.
Oh, great. Awesome. So yeah, today I'm going to be talking about simplifying analysis of hierarchical HDF5 and NetCDF4 files with xarray.Datatree. So that's a really long title. So you can also just go with how trees can help you. So a little bit about myself. Chris already gave a great introduction. So I work at the JESDIS data services at JESDIS as on the data services team. But we're really just a kind of a community of scientists and engineers from all over, including EOSDIS or NSIDC from DAX, and also just community scientists as well. So a little bit on the outline of this talk. I'm going to focus a little bit more kind of technical in the first half. So thinking about JESDIS, big data, hierarchical data formats, X-ray, and then also the data tree model, as well as then next more towards like the open source and open science side of things. So kind of thinking about the partnership between ESDIS and X-ray, and also just computing to open source in general. So who we are. JESDIS is the Goddard Earth Sciences Data Information Services Center. So we're one of the 12 NASA Distributed Active Archives Centers, or DACs. So DACs are generally organized based on subject matter. So our primary data sets deal with like atmospheric composition, atmospheric dynamics, global precipitation, and things like that. But some popular data sets that you might know of are like GPM, which is the Global Precipitation Measurement mission, and also MERA-2, which is like a global atmospheric reanalysis product. So we've got lots of data. And we've actually moved most of our data, our online archive, into the cloud. So this is over 6 petabytes of data, and that number is actually only getting bigger. You can see to the right here, we have like a projected estimate of the Earth Science Center archive. And right now we're probably at about like 100 and, maybe 150 petabytes. But by 2029, that number is going to go up to actually like 600 petabytes. So there is this like, all this data actually also needs to be supported by cloud services, and these services are under active development. So that's kind of where my interests come in as a developer on the data services team. So there is like also just a need to have like a robust way for testing data for testing that our data is like working with these on-prem with these like cloud services. And also a lot of this data is in what's known as the hierarchical data format, or HDF. A note on this, I'm going to be using HDF NetCDF4 and HDF5 pretty interchangeably. I am referring to like the HDF5 specification. So hierarchical data formats are kind of just a model for storing and managing and describing data. So HDF4 was originally developed in the 1980s, and then HDF5 developed soon after that in the 1990s. And this was from the National Center for Supercomputing Applications. So the current specification is HDF5, and it's managed by the nonprofit HDF group. And this is the storage specification that the NetCDF4 file format uses. So yeah, HDF5 is pretty interchangeable with NetCDF4, except for a couple slight differences that I'll mention in a little bit. So some benefits and drawbacks with the HDF5 format. So it supports multidimensional arrays, and it's also self-describing. Prior to HDF5, older storage models, you actually had to have store the metadata in like external tables, whereas with HDF5 and NetCDF4, it's all kind of compiled together. So it's a lot easier to use to find information about the actual product that you're using. So there's also support for heterogeneous data, and it's a pretty open format, so like anyone can contribute or use it. It supports data slicing, which is great because you can actually like get a range of data and then load only that part into memory without having to load the whole thing. Um, and then there's also just broad support for like different programming languages like C and Python. But some of the kind of downsides are it was designed for like on disk access, so it is like a bit difficult to optimize for cloud storage. And the other thing is this format can be complex because you also have spinoffs like HDF EOS and HDF EOS5, which were like NASA derived, and they also have their own like specifications. So HDF5 and NetCDF4, they have groups. So and you can kind of divide like an HDF5 or NetCDF4 file into having like data sets or groups. So like data sets are like the multi-dimensional array of data, and data can have its own attributes and metadata. So I made this little this image highlighting that. I'm sure most of you are familiar with it, but you have you have like a group, which is like the root directory, kind of like the root directory in like a Unix file system. And that group also can have data and metadata. And then you also have the metadata, which is considered sort of like the global attributes for the whole file. Um, and groups can also kind of be nested within other groups. So you can see with this example, this group is nested into group 3, and it has its own data and metadata. And that's kind of just the whole entirety of the HDF5 file. But the difficulty with this is that groups can have like different metadata structures, and like that can vary between data sets. So as someone who's working to make data set agnostic tools, it's challenging to have it's we end up having to kind of like make a bunch of different bespoke tools that handle a specific missions or data sets, like unique group hierarchy. um, yeah, and as I mentioned, yeah, that's one of my primary objectives at the Justice is, providing subsetting services. So then this can also include like things like variable, spatial, and temporal subsetting. And this is for scientists to be able to get data for the specific region or time or like phenomenon that they're interested in um, without having to actually download the whole data set. So there is a real need for this, but it is definitely but group hierarchies can add a challenge to that. And the other thing is we use Xarray a lot. So Xarray's data set model didn't accommodate HDF5 files with a group hierarchical structure. So this was before the 2024 release, 2024.10 release of Xarray. So what would happen is that you would have to basically open each group as an unrelated data set object. And so you treat one data set, you treat one file essentially as being multiple files because they're all unrelated. So a little bit about Xarray. Xarray is a NumFocus sponsored project. It's often considered a part of like the Pangeo stack with XAR and Pandas. But basically it supports labeled multidimensional arrays. So those are like tensor arrays or like n-dimensional arrays. But a good way to kind of think about Xarray is just like it's NumPy with labels. So you get selection through like labeled base indexing rather than like integer base axes. So you'd call the dimension by its name. So dimensions equals time versus actually calling the axis that it belongs to. And Xarray is also really tailored to work for like NetCDF4 files. But the data set model wasn't really well suited for hierarchical data. So a typical workflow for some folks could be like, or at least for us at the DAC, would be essentially using like a different Python package like the NetCDF4 library to get the group hierarchy of the data set. So maybe doing an nc dump or nc4.dataset.groups. And then after you get the groups, using that using Xarray to open them. So maybe doing a for loop with the list of groups. Um, but again, the problem with this is that you actually have to know the group hierarchy beforehand, and then you have to open each group as if it's like not in part of one data set. And then the data sets are also unrelated data set objects. So X-ray data tree kind of solves this problem. So I'm going to go over a little bit on the data set, the data tree model itself. It supports data tree supports opening like NetCDF4 files that contain multiple groups as like a nested tree of as a nested tree. So these groups kind of represent nodes within the data set. But data tree objects also have a lot of those same properties that we're familiar with the X-ray dataset model. So that's like dimensions and coordinates and data variables, and also like variable attributes or like global attributes. Excuse me. Um, but data tree objects also have additional features that help define the relationship between each of those groups. So then with the dataset model, there's this concept of nodes. So nodes in the dataset model actually just represent a group in a NetCDF4 file. Um, so nodes, I'll jump into this example because I think it's kind of a good way to visualize it. So in the data set, in the data tree model, each node is a group within the data set. And each group has all of, has basically all of the features of its descendant nodes. So for example, this root node has metadata, and it's the parent node of all of these other groups. But these groups themselves are also nodes, but they're also data tree objects. Um, another thing about the the data tree model is that it supports inheritance. So if you were like to define a coordinate or like dimension variable at the root group, all of that gets applied downward to all of the other groups or nodes. This is great because it lets child nodes use dimensions that are defined at the top and without having to redefine them. So that like helps reduce the data duplication. Um, yeah, it helps reduce data duplication. It's faster, and like, it also probably captures a little bit more of like the NetCDF4 model. Some cool features are, you can open a NetCDF4 file with multiple groups as like one nested tree. And that's really helpful especially when you have, in this example, you have a data set. So this is an OCO2 light data set that we archive at the JESDISC. And it has all of these different groups, but you can just open them all at once and see how they're actually related to each other. And then in the next example, actually shows it also has this like interactive representation. So in this repro, you can see how each group is related to each subgroup, and you can kind of open it around. Basically allows for kind of ease in like data discovery. Like if you just like wanted to access a specific variable within a group, you can kind of find that a little bit more easily. Some other cool features are you're actually able to map computations over the entire tree. So if you want to like calculate the mean or like the standard deviation, you just do a data tree.mean, and then you choose the axis or the dimension, and it applies that. But you can also like map custom computations. So you can create your own custom computations and map it over the entire tree, rather than having to select which group or like which node or actually which variable that you want that to apply to. You can just kind of do it iteratively. So now I'm kind of going to shift gears a bit to sort of the more open science side of things and like kind of my experience contributing to open source. So we've already been actually able to start using DataTree. Before we were using the standalone repo, which was recently migrated over last year in October. So we've been using it to test all of our cloud services against our on-prem hosted services. And this is just a thing we have to do when we onboard new data into cloud services. And we've already actually onboarded 48,000 granules, which is about 86, which is more than 86 terabytes. So this number is old, but it's probably closer to the order of like 100 terabytes, and that number just keeps growing. Yeah, that just number keeps growing. Um, we also plan to continue to use Datatree for all of our cloud setting services. So that's I'll jump into that. I'll get into that a little bit later in the what's next. So I think a lot of this kind of also ties back to NASA's like open science initiative. So a little bit on that is that NASA's committed to the open sharing of software and data and information, and also supporting like software products that add value to like the earth science domain. And I think we can show. I think I can say that that commitment is shown through the support of um, engineers and scientists like myself developing on open source. So I'm going to talk a little bit more about like how we actually did this and how, yeah, a little bit on like the timeline. Um, so Thomas Nicholas, he was the original author of xarray.Datatree. So this was the standalone repo. Um, and we, and it's yeah, he prototyped it when he was working at Columbia. It's kind of so for a while, it's sort of sitting as like a semi-official prototype for a couple of years, and then I and some of my colleagues at EOSDIS, we become interested in integrating it data tree into upstream Xarray because we have hierarchical data. We have a lot of hierarchical data, and we all kind of saw a real need to do this. And I think I want to sort of note how this is sort of different from like the standard sort of grant funding model. We are like developer users, right? So we use Datatree, and we saw the need for it to be like migrated into upstream Xarray, so it's like generally more accessible. Um, um, and then we were actually able to get retasked into helping with a migration effort. So that was me and my colleagues Owen Littlejohn and Matt Savoy at NSIDC. So and then it officially was released last year in October. So a little bit on the what's next. So we want to continue to developing out data tree and making improvement on it. It is still pretty fresh, but so far, yeah, so far everything's looking and working pretty well. We also want to continue developing with the development of a Jupyter Notebook tutorial using one of our using one of our data sets. So as this data that's highly nested, so we can kind of demonstrate how to use data tree and actually how it's really efficient with handling hierarchical data. And then sort of the last thing is also adapting all of our tools and products to use data tree. That was sort of what I was talking about earlier with our subsetting services, getting our subsetting services to use Datatree instead of having their own sort of bespoke methods of working with grouped HDF files. So yeah, and I'll end with a quote from our former DAC manager. It's that you shouldn't have to download the whole Earth to do Earth science. And I think the sentiment is definitely really captured in this partnership between as this engineers and scientists and X-ray. Yeah, so I want to thank everyone at JESDIS, and thanks Chris for the invite. My colleagues at ESDIS and NSIDC, which are Owen and Matt Savoy, and also the whole data tree team. This definitely was something that was a group effort. Cool.
Yeah, thank you so much for sharing that, Annie.
Thanks.
Before I start asking a couple of questions, I would like to see if anybody else has any other questions. We've got plenty of time. Okay, well, I could probably go ahead and get it started. So, uh, does the data tree model with HDF files, I know that HDF files have lots of this metadata that has to be streamed in unless you're downloading it, which could create some delays and some latency, if I'm understanding correctly. just from previous experiences with working with HDF files. Does Datatree help make that process become more efficient with I/O and things like that?
Yeah, so Xarray natively supports like lazy loading. So do you mean like when you're like it's like an opened app URL, or if you're accessing data in region? Yeah, definitely, yeah. So Xarray supports like lazy loading. So you only get the bit of the data that you want that's stored in memory when you actually load it. So it does make that process a bit faster.
Yeah, that's great. I'm hoping that it can be used in some of our maybe some of our level 2 how-tos with a lot of the HDF files in there and just the loads of nodes and children that are in a lot of those granules, which I know can make it quite large. I wonder, would that help make it more searchable when performing things like subsetting and stuff like that, make it a little bit more efficient?
Yeah, I think that's what we've seen. So a little bit about kind of the tools that we've been using Datatree with. So um, we have a tool that basically validates our on-prem services against our cloud-hosted services, and it looks when it gets a data set with groups, it actually um, when we use Datatree, we get all of the groups at once, and that's like simplifies the process rather than kind of iteratively like going using a for loop to like loop through all the groups and then check, oh, does this match between this one group with this one data set that A versus B. So that's what we've been seeing, that it's definitely been sort of streamlining the process, especially when you have yeah, like level 2 collections that have like 25 groups. And yeah.
Awesome. Yeah. And I guess for folks in the audience who might not be aware of that, we've got these different levels of collections, and it basically has to do with how the data comes down from the measurements and goes into the data center. And so level 1 and 2 are typically ones that don't have gridded data on them. They contain the latitude and longitude information in units, but they are typically stored in HDF files or sometimes NetCDF, and NetCDF is built on top of HDF. But you could have, like you said, 25 different groups, each of those groups representing different quality control things or various metadata. And this metadata can get quite large. So I'm certainly looking forward to seeing if we can make that a little bit more streamlined in some of our tutorials as well. Um, do you have any, I guess, demo notebook links that you've made in this collaboration process, or anything that you know of that the users could get started on after this meeting, maybe?
Yeah, so we do have some docs, but a tutorial is actually what I'm working on, so that's kind of on the what snacks. And I do want to make a tutorial with one of our data sets, so like a gridded product, but that has groups, and kind of just showing the process of using Datatree to plot data and to just also examine the data. But I can definitely share just the general documentation for folks.
Yeah, that'd be great. Um, yeah, and then I guess the only other question I had was for the collaboration effort, that was through the Pangeo group. And I guess for those wanting to get kind of more involved with some of those open science contributions, would GitHub be a good place to start with that? So let's say someone has an idea for a feature in Xarray or something. Is that where you went first and you opened up like an issue or something?
Yeah, I would say GitHub is definitely a great place to start. I think that's where most people are at. It was a little bit. I think that's also so. Owen, who's our colleague at EOSDIS, he discovered the data tree, Xray dash data tree, which was a standalone repo, and he was really interested in it. But we kind of wanted something. We wanted something with broader support, because Xray is a num focused back project. And before we could commit to actually just using data tree, we wanted to see that that was something that could be used. So that's why we decided to migrate it. And I think he did just reach out to folks on GitHub. So I think that's just a really good way. GitHub, Pangeo also has a lot of, they have like monthly meetings for, I guess they're kind of just like demos for like sort of the new tools and stacks that they're working on.
Yeah, that's awesome. I see Keenan has his hands up, or his hand up, I should say.
Yeah, just the one. Um, one question I have is one thing I use a lot with Xarray is using like the various backends that are available, like whether the data underlying is a xarray or Dask or so on, and kind of the lazy computation graphs that show up with that. One question I have is if I am manipulating the tree structure at all, do those manipulations remain lazy, or will Datatree like pull all the data into memory to do that computation?
Oh, that's a really good question. So if you're doing those like, are you ever writing them in the process, or are you just doing it all in memory?
I mean, I don't really have a specific use case because personally I've never used Datatree, but I guess I'm just wondering like if I clip a branch of the tree and then I want to move it somewhere else and that underlying data is like Dask or something else that isn't in memory, will modifying the tree structure trigger that data to get pulled into memory as
Um,
opposed to operating on it like in chunks or staying lazy or what have you?
yeah, I'm not too sure on that answer. I think it would still remain lazy, but I think that's something I would have to check on.
Okay, thank you.
Yeah.
All right. Does anybody else have any other questions or comments? Okay, well, if not, I think we'll go ahead and conclude early. Annie, thank you so much for
Yeah.
allowing us to hear about your work on this and giving your time with us today. I hope that we can continue to learn more about this and maybe connect with some of the other attendees at any other future meetings or things like that. So I want to thank you again for joining us today. Um,
Awesome. Thanks for the invite.
Yeah, of course. And with that being said, let's go ahead and conclude. And I would like everybody to stay peeled to the calendar to see our next speaker to come up for the March webinar. We're still working on that. So with that being said, I want to thank everybody for joining and have a good rest of your day.
Thanks.